originally didn't intend to do this paper. I wanted to do the other one.
Yes, the anchors.
But yeah, I think Alex misunderstood what I meant when setting the bet. I don't really care, so let's go do the Taiwan only because it's easier right now than fixing the YouTube event and whatever.
Okay. I
if
would
people
prefer
want,
the other one myself.
we can also do the other one. I will still change the title in YouTube later.
Yes, every meeting. Oh yeah, we got a recording.
Oh yeah. Sorry, Alex told me something about that. Okay, yeah. So the recording is working now. We are being recorded now. Anyway, so my main question is: do people care if we do this one or like the thought answers one? I mean, we are going to do the other one next week anyway. So
Personally, I'm more interested in the other one, but also I have to leave in like a few seconds, so it's a bit stupid that I say do the other one and I'm not here. So
I
it's your
feel
choice.
like more people are there are more people interested in the other one that are not are not here today. So I think I'll just do this one that seems comparatively less interesting, maybe.
There's 2 reading rooms.
And we'll do it next week. I mean, we'll do the other one next week. And yeah. Anyway, getting to the actual paper. Oh, the other person also left. Anyway, so what's this tide thing again? Let me also let me do. Also, yeah, it's not for the Discord icon, it's for the YouTube thumbnail, default thumbnail thing. But yeah, that one could work. I think I have another idea, but we'll see later. Anyway, diffusion transform. Okay, so first, what's this style thing about? Yeah. Diffusion transformers are powerful generative explorer class or generative models compared to UNet-based diffusion architectures. They propose tide. So this is like for trying to do sparse autoencoders but in diffusion transformers. I'm not sure exactly how the details of how diffusion transformers work. Like I know what diffusion is, I know what transformers are, and I guess it's just some combination how transformers and doing diffusion. But yeah, not haven't ever seen the details of that. But okay. And they do some kind of temporal-aware Sparse encoders. So they use some kind of Sparse encoders that works with diffusion. High effectively controls temporally varying representations and reveals that diffusion transformers naturally learned hierarchical semantics, large scale pre-training. Okay, so this paper, for what the author says, basically about doing some kind of transformer like some kind of special diffusion sparse encoder that probably takes about like multiple steps and something somehow works. Doesn't yeah, this is the typical thing about why image generation is cool or whatever.
I'm trying to understand the difference between the taking the activation space across timestamps from just simply saving the activations. What's the difference?
Sorry, which part of you? Oh,
I was looking at the abstract.
Oh, that's that. So we'll see. But like the thing is, during when you do diffusion, you are like doing multiple steps of taking the image and putting it through the model, right? Like the typical thing. Well, now they do Latin style space diffusion, but originally you have some blurry, like some random noise, and you apply the model multiple times, and it starts looking less like noise and more like the image. So I'm guessing they are doing something where like they take the activations in some layer for all of the steps or something, and maybe they do some math to them that will have to read the paper to know, and combine them to get the sparse encoder activation or something. I don't know. Yeah, but it has to be something related to that. Yeah, diffusion models, temporal dynamics. This is what's explained here. Diffusion transformer refine light representation across time step, integrating multimodal inputs from test decoders. Mm. The percentages, high to dimension, temporal intuition patterns. Uh-huh. Okay, so to address these issues, they make this tie thing. Okay, so how does this work? Uh, yeah, I don't know. It's loading now.
I think it's later on in the paper. I think they haven't shown how they exactly proved that the part they add up the different steps correspond to a certain image. Maybe they found a way to force image generation at certain parts and then trained a sparse autoencoder on it or something.
It seems like here they are doing something where, like, in parts of the image, they are detecting features like that there is a house in the image. We'll see how exactly they do that. Maybe they have some lab, but then it will be. Yeah, I guess they just run a sparse the sparse encoder does that. Windows. Okay.
Not sure what they mean by the progressive sparsity scheduling. Like, it's kind of vague. Like, do they do it on every step or every few steps?
Temporal-Aware, yeah. I wonder what sparsity scheduling means in this context.
Yeah, like
normally
it could.
when you sorry, what are you saying?
Yeah, I also found it confusing on that part. Just
So basically, normally when people talk about sparsity in sparse encoders, like the way the sparse encoders are sparse is that you train them with some sparsity penalty or whatever, and then the model just learn to have sparse representations.
yeah, it was a Sparky constraint.
Yeah, you can also do like top K or whatever, but I don't think they mean that. Maybe they do, but so I'm not sure what changing the sparsity would mean unless they train it or something differently. But yeah, they need to read more, I guess. More people. Scaling law and evaluation. Scaling law, yeah, interpretation, whatever. Special applications. They. Oh, nice. This is the. I wonder if this is the thing. Who made this? No, it's not the thing from.
Could the sparsity scheduling be like training like another sparse autoencoder like for every like step or something?
I think we can
Make
just
it
go to
controllable.
the wait until we get to the part where it does actually explain.
I guess I should.
And then we just. But yeah, it seems like they also. I've seen other things that was similar, but I think that wasn't with diffusion. Where they it's like the thing they say here, where they are using sparse. They're using this thing to edit images, which is nice. Okay, nice tide. Oh, they have a figure here for the training process. Let me zoom on it to see if it explains anything or we need to get to the next. I know the formulas are not very visible, but okay. So they have the diffusion thing, and they do some mask based on extracting activation layers from different times of each time. Activation layers from different times of each time. Yeah, I don't know. Let's go to the next part to see if they. No, it's not. It's not loading very well for some reason. Anyway, related work is just talks about first encoded interpretability and there's also other diffusion model interpretability things. Sparse encoders. Yeah, this is just explaining what sparse encoders are and top K application. Oh, they do top K sparse encoders. Makes sense. It's just to pick the top activating examples.
I don't think the paper said the K value yet, or maybe it's in the methodology.
Yeah, that's probably. Diffusion transformer. Where to train sparse encoders. Right here. Activations are extracted from specific transformer layers during both the forward diffusion and reverse denoising process. Okay, so given an image and a text prompt, the image is encoded into the latent space using an autoencoder. Noise is added to simulate the diffusion process, producing a noisy latent. Simultaneously, the text prompt is embedded into whatever embedding, I guess, via the text encoder. Latent and text embedded frame the transformer model, which hooks got to activation for doing the forward pass. Activations are then used to train the Sparse encoders.
I wonder how they added the temporal information to the activation layers. Did they add like a temporal position or something, like the positional embedding?
Okay, so they have the activations from different. So first they're doing a weird thing where they are taking the image and adding noise like they do on training, and then running it forward one step with activations.
If I understand correctly, the temporal the temporal information is basically just using the positional position of the token and then adding a K value or a T value for how long that one token will take. So just adding the length of how long the token takes. I want to ask about the second paragraph.
So they basically just train the normal Sparse encoder, but the Sparse encoder has something that tells it where the time, like which step it is.
Yeah, and they determine the time based on the T value on the second paragraph. It talks about how much information present. I'm not sure how they determine that.
They just do it. Like they are just generating the data, so they know which time is it. So they just need to add it to the model.
From how I understand this seems to be like they're adding the T value or how big the data is on top of the positional embedding.
Yeah, makes sense.
But why would adding a T value make a huge difference?
So basically, I think the idea is that if some activations mean different things depending on the time, the Sparse encoders can take that into account.
So the sparse autoencoder just automatically takes it into account after you added the new direction.
It has you add the time, so the Sparse encoders can learn that some other activations, and at some time means something different than at some other time. Wait, yeah. Okay. So they are doing scaling. Yeah. But they do some add something to the image based on the time. It's yeah, the train on whatever GPUs. They compare Sparse encoders with their typing. Sparse encoders with just train on random time steps without giving the time information. And they find that it's better. I mean, this kind of thing is always suspect because sometimes people just mess up the baselines. But okay. Level sampling improves learning efficiency by focusing more on informative local features, while also mitigating the impact of global noise, leading to better generalization. There is sensing MSC. Scaling loss understand the source state. So they do scaling loss. We possess the accurately capturing the state of the model requires a large number of parts features. To address this, we propose two primary approaches for determining the size of the autoencoder and the token budget. Right, yeah, they change the dimensions of the autoencoder. Okay. Here it's they basically ask if the diffusion model really encodes things that you need for doing classification or whatever. Okay, and they have some images, extractivation from the model. And they compute similarity scores between the input image and identified tokens. High similarity. Yeah. So they try this. They find some activations that seem to activate for some images they have for specific contexts, and then see what they do. And they have something that seems to be represented for near and shadow. Yeah.
I wonder if they made sparse autoencoders before using the adding tide, like the temporal aspect, to see like which features they capture
Yeah,
that
I
were
think
originally captured.
I also you will have to look at the other things people have done on the diffusion models because those are the ones that have time, and other people have to have dealt with time in some way. Maybe not in but yeah, in this exact way. House, window, and door. I know it's apparently for what it was saying, Shea-Jay did already did something like about right to that. The final reality die identify. Okay. Anyway, going back to this, yeah. So there has some bigger features that have subcomponents like here the code, how Rococo activates house, window, and door, whatever. Uh, okay, so this is just they tried, and it seems like at least some features make sense. Mhm. Yes, it's just about some this part is about uh, applications where it's a bunch of things that they could use for like deleting or adding features. Oh, scaling activation indices to achieve feature transition. That could be cool. Like you do something like this where you uh, change some. You do some change and you can do some smooth change where you slowly scale something and you transition for something like you could have some young person that becomes older or something. I feel like there is I already seen some, but I feel there is some people will probably make based on Mech Interp, like one of them earlier application is going to be like people doing some custom tools to do cool things with image models that let you do more specific things than just ask with a prompt what you want. Okay, so this is just about heavy parameters. I don't like when people talk about safety evaluation. I don't know when people talk about safety in the context of removing not safe for work content.
I guess as preventing possible misuse, I'd be more interested in the possibility of preventing like encrypted messages through images.
I think they
Or-
more they. I think I like the description that Eliezer did on Twitter of like this is basically brand safety. If anything, but yeah.
Yeah, it'd be cool if you could like remove the ability to do stenography or something with images for the models.
Yeah, that would be interesting. But yeah, here they basically, what they mean by safety here is just they try to make it not
Company
make
profits.
not.
The shareholders are the most important things.
Yeah. They don't want Visa to censor them.
Yep.
Yeah. So yeah. I think we was actually imagine this and just okay. So basically, it's in the works. For the sparsity. But yeah, I guess there is not a lot more about this paper. Yeah, it is not the most interesting one, but I kind of prefer to do the other one, which is more interesting next week when there is hopefully going to be more people.
I would have been interested if they were trying to maybe like instead of just adding the time direction, I was like I was imagining more like they were adding the time direction and then forcing the model to generate at certain parts, something, or like use like resampling like the black box method from the other paper.
They just had the time, so I mean we could get into exactly how they have the time. It seems like this is just a Sparse encoders. I mean, it's a nice idea. Like you take this Sparse encoders and add the time, and that works. This also tells us like the fact that this works, assuming they didn't mess up the other the evaluations, which is not that unlikely, but assuming they didn't, this might tell us that the models do like do represent things at least somewhat differently when you on different time steps. It might also be that there is some effect that you need to cancel out from the from all the random noise. But still, you will. It was still mostly the same. You would expect if you train with random images to just work assuming it's all linear. Maybe not. Like maybe the activation for some birth looks different than when it's mostly a bunch of noise and some bits of birth, and you need to add the time so it notices the same. Is the same, so the other person coders can identify the same thing. I don't know. it just seems like the fact that time helps noticeably means that the model does care. Like
Did they
the model
compare it to
does.
sparse autoencoders without time though?
Yeah, they compare with Sparse autoencoders without time, like here, and they get like slightly lower. Not sure. Well, on this metrics basically. I don't remember what MSE standard for.
I wonder if the model treats the time direction like with the T, the add for the size, similar to like the position. Or like how do they treat it differently?
Sorry, can you repeat that?
I wonder how the model treats the T, like activations or the T direction from the size.
The model doesn't have the time. They just add it to the Sparse encoder. Also, some people are writing on the chat. I was not. I wasn't paying attention. Also, okay, that explains why the PDF was also not working on my like was working weird on my computer. Apparently, this figure is like super high resolution. It's also weird. Like the figures of this paper are wrong. Like they are too. You need to zoom a lot to read them properly.
This felt more like a lit review than a paper.
Yeah, and it makes sense that
They were giving a summary of other research instead of. I think it was like 50%.
I guess it's more that they don't have a lot of original things. They just took the previous work on diffusion, transformer, Sparse encoders, and added their some time encoding, and that's mostly it. And then they tested a bunch of ways of saying or method is pretty cool and whatever. I mean, I think that's a fine kind of paper to make. You don't need to make up some super new thing like the Wang's paper. But yeah, I think it's okay. But there is no. I don't think there's. I have a lot more to talk about it. But people can like just. I guess I can wait. Maybe people can try say something if they want me to look into some specific thing or like want to comment something. And otherwise, we can just leave it and do the thought answers one next week, which will hopefully be more interesting. I was going to do it this week, but yeah, I kind of miscommunicated with Alex to when he was setting the event. I decided that since there were not a lot of people, I might as well just do this one, and we'll do the other next week, and hopefully there will be more people. Oh, what they did, I didn't figure out is they mentioned the scaling. Yeah, they mention the thing where they supposedly change the sparsity, and I'm not sure.
Yeah, did they explain the temporal sparsity? Whatever that was earlier on.
Yeah, I'm not sure I understand it. Because here they talk about so figure 3. So they say they do timestamp dependent modulation into the original Sparse encoder architecture, but I'm not sure what they modulate exactly, because here they say x mod is like x multiplied by the scale, see whatever, right? But this is, I understand x is just the image, so that's just changing the image so it has some temporary information. But I don't know what has to do with sparsity or the yeah, or sparse encoder architecture. Oh, so MSC was just mean square error, sparsity loss.
I wonder how they got the name temporal information when it's literally just the T, or maybe their temporal information is different from what we saw with the T shift.
I think there's also, they don't have any appendix or anything explaining the. So, yeah, I don't know. I still don't understand it. Also, they don't use the regularization. They just do top K. Like, also, yeah, so here it says this modulation terms the scaling of shifting. The scaling of the image, because here they are doing a scale of T and they don't this doesn't take the image into account at all. Maybe they do, and it's just bad notation. I feel like this paper is kind of badly explained. There's also there was this image here. It feels like there are things on this image that are not even displaying on anywhere on the paper.
Maybe it's in the appendix.
There is no.
Or they don't have an appendix.
Yeah.
What?
I don't know.
There's no appendix or anything.
No. It's kind of weird. And they just. So they do this mask thing. I don't. Yeah, I don't know what this mask thing is about. And what the. Like why they are masking some image. And then they do whatever this formula is. Kind of hard to read. I don't know what it means. I don't see this anywhere else in the paper. It's just kind of annoying. Like, why do you put like formulas in your in images that you don't even explain anywhere? Maybe they're explaining. And no, I don't think it's like the times the Huang of test. Whatever this is, or reply by clip the delta D X. No idea. Okay. So yeah. Mainly what I have learned here, that first they did something where they add the temporal information into the layers before the Sparse or something called, and that works better. And also they maybe did something else with the sparsity, but they didn't explain it correctly, and the paper is kind of not super well made up written. Which also like makes me think it's more likely that they did the thing where they made a bad Sparse encoder, and then on a surprise or thing works better. That is like a very common thing in papers, and the worse the paper is, the less I trust they did the baselines correctly. Yeah, but that's what I get from the paper.
Maybe the increase in the temporal sparse autoencoder might not just be due to the time, but might be due to like the fact they increased the sparsity. Maybe they kept the increased sparsity that increased the performance previously.
The normal thing, no, I think they say, I think they subtract the same sparsity. It's also possible. I think there are a bunch of ways of messing that kind of thing up by accident. And it's very easy to see that you got the result you wanted, which is that your method is better, and stop. That's why people keep finding the problems with the papers later on with this kind of thing. I mean, I wouldn't be surprised that the temporal thing does work. It's just saying I'm much more suspicious that if the paper looked super nicely done elsewhere and didn't have any problems. Yeah, like for example, something that people can get wrong is here they use the same configuration, but maybe actually all the Sparse encoders work better in some other configuration, and in most configurations even. It's just happened they find some weird configuration where the the type works better. Yeah. Yeah, that's mostly it, I guess. Does anyone else want to say anything, or do we just leave it here?
I have no more thoughts on this. I have also
Okay.
I have more thoughts on the thoughts.
Yeah,
Of this paper.
I already that's understandable. I already didn't have a lot more thoughts. I was just trying to see if I could figure out the sparsity thing, but it doesn't seem like it's even explained anywhere. Maybe I'm missing something, but maybe it's just in how this shift thing works. I don't think they explain what the operation even is. Anyway. Because if they mean something like just scale the image or something, which I'm not sure what that even means in terms of the image, but whatever. Like in terms of activations. Yeah. Anyway, nobody's saying anything, so just stop here, I guess, and we'll do next week. After this, I'll set up the mental rate instead of waiting until last minute like today. Next week we'll do the thoughts and short paper, which it seems more interesting. That's it, I guess.
For that paper, I think you should also show the demo and explore that also as well, since that's also part of the paper.
Oh
yeah, that'd be good.
I haven't read it yet, so I didn't know there was a memo, but yeah.
I used it a little bit. It's pretty cool.
Yeah, we can look at it next week. Yeah. And I see that the fact that you and the other person already read it will be nice, because then we will probably have more discussion, unless me just reading the paper.
I read the paper before, so I could discuss more on the other paper instead of this one.
Yeah. So next week at the same time. Yeah, I'll just tell Alex to stop the recording. Yeah, but that let's. Oh, I see you are muted. I but didn't say anything. I don't know if you wanted to say something.
Oh, me? Oh, I just want to say thanks.
Okay. Yeah. You can leave now. I'll wait a bit to see if the recording thing stops. But
Can you kick out the recording? Don't you have the perms to kick it out?
Yes, yeah, I guess I can kick it out. Kick it out.